Hi, and welcome to another Security Bear tutorial. I am here to talk to you about NetFlow. NetFlow is a network protocol developed by Cisco Systems for collecting IP traffic information. NetFlow has become an industry standard for traffic monitoring and is supported on various platforms. Routers and switches that support NetFlow can collect IP traffic statistics on all interfaces where NetFlow is enabled, and later export those statistics as NetFlow records toward at least one NetFlow collector, typically a server that does the actual traffic analysis. A network flow can be defined in many ways. Cisco's standard NetFlow version 5 defines a flow as a unidirectional sequence of packets that all share the following 7 values. 1. The ingress interface. 2. The source IP address. 3. The destination IP address. 4. The IP protocol. 5. The source port for UDP or TCP. 0 for other protocols. 6. The destination port for UDP or TCP. Type and code for ICMP, or 0 for other protocols. And finally, 7. The IP type of service. Note that the egress interface, IP, next hop, or BGP, next hops are not part of the key, and may not be accurate if the route changes before the expiration of the flow, or if load balancing is done per packet. Please check with your network operator if any of these things are configured or are likely to occur. That definition of flows is also used for IPv6, and a similar definition is used for MPLS and Ethernet flows. Advanced NetFlow or IPFIX implementations, like Cisco Flexible NetFlow, allow user-defined flow keys. Again, please check with your provider or operator to find out whether this is enabled. The router will output a flow record when it determines that the flow is finished. It does this by flow aging. When the router sees new traffic for an existing flow, it resets the aging counter. Also, TCP session termination in a TCP flow causes the router to expire the flow. Routers can also be configured to output a flow record at a fixed interval even if the flow is still ongoing. Check with your provider or operator to find out which way the network you monitor is configured. NetFlow records are traditionally exported using User Datagram Protocol (UDP) and collected using a NetFlow collector. The IP address of the NetFlow collector and the destination UDP port must be configured on the sending router. The standard value is UDP port 2055, but other values like 9555 or 9995 are often used. For efficiency reasons, the router traditionally does not keep track of flow records already exported. So if a NetFlow packet is dropped due to network congestion or packet corruption, all contained records are lost forever. The UDP protocol does not inform the router of the loss, so it cannot send the packets again. This can be a real problem, especially with NetFlow version 8 or version 9 that can aggregate a lot of packets or flows into a single record. A single UDP packet loss can cause a huge impact on the statistics of some flows. Please bear this in mind when using NetFlow for correlation, or for the sole trigger of alerts or incidents. That is why some modern implementations of NetFlow use the Stream Control Transmission Protocol (SCTP) to export packets so as to provide some protection against packet loss, and make sure that NetFlow version 9 templates are received before any related record is exported. Note that TCP would not be suitable for NetFlow because a strict ordering of packets would cause excessive buffering and delays. Stream Control Transmission Protocol (SCTP) is a transport layer protocol, serving in a similar role to the popular protocols Transmission Control Protocol (TCP) and User Datagram Protocol (UDP). It provides some of the same service features of both. It is message-oriented like UDP and ensures reliable in-sequence transport of messages with congestion control like TCP. The problem with SCTP is that it requires interaction between each NetFlow collector and each router's exporting NetFlow. There may be performance limitations if a router has to deal with many NetFlow collectors, and a NetFlow collector has to deal with lots of routers, especially when some of them are unavailable due to failure or maintenance. All NetFlow packets begin with a version-dependent header that contains at least these fields: version number, version 5, 8, 9, or 10, sequence number to detect loss, and duplication timestamps at the moment of export, as system uptime or absolute time. Number of records, seen in version 5 or 8, or list of templates and records as seen in version 9. A NetFlow record can contain a wide variety of information about the traffic in a given flow. NetFlow version 5, one of the most commonly used versions, followed by version 9, contains the following. Input interface index used by SNMP, F index in IFMIB. Output interface index or 0 if the packet is dropped. Timestamps for the flow start and finish time, in milliseconds since the last boot. Number of bytes and packets observed in the flow. Layer 3 headers. Source and destination IP addresses, source and destination port numbers for TCP, UDP, SCTP, ICMP type and code, IP protocol, type of service, TOS value, for TCP flows, the union of all TCP flags observed over the life of the flow. Layer 3 routing information. IP address at the immediate next hop, not the BGP next hop, along the route to the destination. Source and destination IP masks, prefix lengths in the CDR or CIDR notation. For ICMP flows, the source port is 0, and the destination port number field codes ICMP message type and code port equals ICMP type multiplied by 256 plus ICMP code. An example would be Transport Protocol ICMP with a listed source port of 0 and a destination port of 2048. 2048 divided by 256 equals 8. We can surmise from this that the ICMP type is 8 and the code is 0. This was an echo, although this must be confirmed by your vendor, provider or operator. Contact them for more information. NetFlow version 9 can include all of these fields and can optionally include additional information such as multi-protocol label switching, MPLS labels and IPv6 addresses and ports. By analyzing flow data, a picture of traffic flow and traffic volume in a network can be built. The NetFlow record format has evolved over time, hence the inclusion of version numbers. Cisco maintains details of the different version numbers and the layout of the packets for each version. NetFlow is usually enabled on a per-interface basis to limit load on the router components involved in NetFlow, or to limit the amount of NetFlow records exported. NetFlow usually capture all packets received by an ingress IP interface, but some NetFlow implementations use IP filters to decide if a packet can be observed by NetFlow. Some NetFlow implementations also allow the observation of packets on the egress IP interface, but this must be used with care. All flows from any ingress interface with NetFlow enabled to any interface with NetFlow enabled could be counted twice. Please bear this in mind when analyzing NetFlow data. Standard NetFlow was designed to process all IP packets on an interface. But in some environments, for example on Internet backbones, that was too costly, due to the extra processing required for each packet, and large number of simultaneous flows, so Cisco introduced sampled NetFlow on Cisco 12000, and that is now used in all high-end routers that implement NetFlow. Only one packet out of n is processed, where n, the sampling rate, is determined by the router configuration. The exact selection process depends on the implementation. One packet every n packet, in deterministic NetFlow, as used on Cisco 12000. One packet randomly selected in an interval of n packet, in random sampled NetFlow, used on modern Cisco routers. Some implementations have more complex methods to sample packets, like per-flow sampling on Cisco catalysts. The sampling rate is often the same for all interfaces, but can be adjusted per interface for some routers. When sampled NetFlow is used, the NetFlow records must be adjusted for the effect of sampling. Traffic volumes, in particular, are now an estimate rather than the actual measured flow volume. The sampling rate is indicated in a header field of NetFlow version 5, same sampling rate for all interfaces, or in option records of NetFlow version 9, sampling rate per interface. Thank you for listening. I would like to thank Wikipedia and Google for enabling me to cut and paste into this presentation. Goodbye.